Today's talk will be how we ended up in InfoBip with HAProxy Web Application Firewall. Basically, what were our challenges, why we needed Web Application Firewall in the beginning, how we tested Web Applications Firewall, and how we made up with the decision why we are going with HAProxy Firewall. And we will also talk a little bit beyond just classic Web Application Firewall and signature-based with some, let's say, behavior-based strategies. And what are our further plans with HAProxy? So our company basically is already introduced, but yeah, we are just a company that provides ability for businesses to connect with their clients via various channels, and we are all around the globe. Basically, we have 62 data centers at the moment in probably every region in the world. But what is important for our presentation is that last year on the Black Friday, we have more than 80,000 transactions per second, and all those transactions went through HAProxy and HAProxy Web Application Firewalls. These two nice pictures are basically our two biggest. The upper right one is basically Vodnjan, our headquarters, and another one is in Zagreb. It's, let's say, like a biggest engineering spot of InfoBip. So let's say almost 2 years ago, we started to test different web application firewalls. But before we continue further with how we decided, it's important to know what we already had. We already had SSH proxy, HAProxy, deployed in our data centers as load balancer, working as reverse proxy also. And we already were doing SSL interception, basically SSL termination with HAProxy, and we already had that stuff automated. So SSL renewals and everything was already automated. Everything was in high availability, and what we like in our production basically is that our services are run as containers. So this was one of the benefits of the HAProxy, is that we can run it as a Docker container, and basically that is how we run everything in our production. And we also had high volume, let's say, networking, high volume DDoS protection, but that is not enough, especially for the application DOS attacks. So we will see how we cover that with HAProxy. So what were our, let's say, challenges? We could say the challenges are the same like in every other company or similar to other companies worldwide. We want to get better visibility into attacks. We want to see what is happening, who is attacking us. We want to remove that burden of malicious traffic from our backends. We want to protect against known threats and hopefully against unknown threats like 0 days, like Log4Shell and different kind of attacks. But there is this important thing like compliance. So as we are dealing with the clients, basically with our customers, I think that almost every customer, when they send us the questionnaire, there is a question: do you have Web Application Firewall? And if we say no, there are some clients that want to sign contract with us. So there is also a business thing why we need to have a firewall. And that is also something important for us is custom rule set. What we want to do basically is custom signatures that are tailored to our applications. So we also utilize bug bounty programs. So what we want to do when bug bounty researchers found a vulnerability, we want to basically fix it fast as we can. We will fix it first on the Web Application Firewall with custom signature, and then we have time for the developers to test a fix and deploy it to the production. Our biggest challenges when we talk about Web Application Firewalls is basically our design, our 62 data centers. And every data center holds HAProxy and holds Web Application Firewall because we want to do business in a way, if one data center is down, we don't care. If all data centers is down and only one is working, he must work for itself. So we don't want to have reliability between data centers. And another thing is our solution needs to have really, really low latency. When we implement a new solution in the InfoBip, we are not allowed to introduce new latency. Why? Because we have our clients, we basically have customers with which we have a contract with dedicated request and response time. Basically, we have clients with dedicated latency. Then we started to, let's say, watch different solutions, different vendors. Here, they say privacy concerned with cloud-based solution. It is one-off, but I'll go to next slide. So when we talk about cloud solution, we also investigate software as a service solutions, web application firewalls, vendors, what they are offering. The first issue that we had is, does it have presence in all the regions where we are? That was the first question. Second question is, if they are start processing our traffic, maybe we need to announce, we need to say all of our clients that we are now using a sub-processor. Then this cloud provider should become our sub-processor, and we didn't want that. If we take a look at the hardware appliances, we are not satisfied with the scaling. And the price just go high rocketing because you cannot scale it efficiently over all of our data centers. And we also don't like virtual appliances because our motto is everything should be inside the containers. And in that way, we can scale it as we like, because we just deploy it and we deploy servers and containers in the number of minutes. So our first decision was logic one. Let's try with the HAProxy. Yeah. We contacted the HAProxy. So Boris, how did it went?
Yes, so we reached to HAProxy and they presented us with two different WAF solutions. Advanced WAF with its fast WAF engine and mod security. Mod security uses core ProSet, which is de facto standard, and it's used by many other vendors. So how did we test? Well, we deployed one instance as a Docker container, and we started with testing. We used the tool Vegeta, which is HTTP load testing tool, and we had two different scenarios. First one was we hit that instance with 2 minutes of different requests per second, and the other one was, well, we captured test traffic in duration of 13 minutes, and we just replayed it, but 3 times faster. So on the left side, you can see latency. So with advanced WAF and without WAF, latency is minimal, but mod security introduced some latency here. And in the third set, we couldn't even measure that latency. So on the price side is the replay attack. So again, advanced WAF and without WAF is the same, but well, mod security hits through the roof. Yeah. So here we must mention that we have both API and web portal. So on the API, we see much high volume of the traffic than on the web portal. So here, WAF must be able to handle all that volume. So regarding our testing, advanced WAF, well, it failed on the web portal. Why? Well, because it was too much aggressive, so we couldn't create a whitelist here, where mod security failed on the high throughput API.
Yeah, so basically the difference was just like a web application has less transactions per second, but it is much harder to fine-tune because it's a web application. On the other hand, API have a clear structure, much more transaction, but it's easier to be fine-tuned. Then we again went back to the HAProxy. Look, guys, this will not work. Why? Because we don't want to have two solutions. We don't want to have two different vendors for the application firewall, like one for the portal, another one for the API. But it was a plot twist because we contacted them, and HAProxy guy said, okay, we have a new web application firewall called Intelligent WAF. At that moment, it was like chained WAF, now it's called Intelligent WAF. And everything that you see on slide, it's nice. It's nice if you look at the brochure. I mean, they created the engine faster, more optimized, better. But what is important is under the hood. How does it actually work?
Yeah, so basically it's again same advanced WAF with ModSec, but now advanced WAF acts as some kind of smart filter, and it attracts just suspicious stuff. So mod security will that inspect again, and also they introduce this new feature where you can limit the DCPU. So mod security won't hit the limit of the CPU. Yeah. So it offers best of advanced WAF, which is fast engine, and core preset of ModSec. So we tested it and it went fine. So we implemented it on the portal and then on the API.
Now, when we knew that the stuff could work and the testing was success, we need to create, a plan. How are we going to implement it in all of our data centers? So we will start with deploying the application firewall in all data centers, but in the learning mode, basically in the monitoring mode. Why? Because we don't want to break stuff. We choose at the beginning fail open, or basically we choose availability over the security. Because while we are learning the traffic, we are learning how our application behaves, we are learning the request, we are learning everything. We don't want to break the production. So if CPU is above 80 or 90%, then turn off the web application firewall. We will review the logs, alert us when that happens. We will review the logs and we will see, is it actually an attack, or we need to fine tune something. We need to remove something that is not going through this smart filter to the CoreOS compatible engine. And to do that, we of course configure the syslog. We ship everything to our log management solution. We created there the alerts, searches, dashboards, and everything that was needed. Why? Because when we started, Fusion was not on this level that is currently. So that's something for the future. And from the beginning, as we have 60 data centers, everything must be automated from the central location. Why? Because if we create some small change, I don't want to do it manually. It needs to be deployed inside the 15 minutes all around the globe. So this was our, let's say, baseline. Now when we have baseline, let's see, can we switch from the monitoring mode to the protection mode? And then it's OK. We have a product documentation. Great. So we can match what is actually happening from the logs, and we can match with our product documentation. Is it like a false positive or not? But where is the challenge? The challenge is in our design, because we are utilizing like this microservice design, where we have one full qualified domain name, like API, InfoBip.com, and then every path is basically another application. Like SMS, one application, one backend. RCS, another applications, another backend. Email, WhatsApp, Viber, etc. Everything, we should look everything as a separate application. So we cannot enable the application firewall from once on everything. We need to create a plan. Basically, what we did, we put everything inside the monitoring mode, and then we watch path SMS, fix it. Be sure that there is no false positives. After you're sure there is no false positive, turn that path into the protection mode. And then we go application by application by application by application until we finished all of the application. And then we switch the logic. Everything should be protection mode unless we created a path that is in learning mode. Why? Because it's a new application. And then, again, central configuration comes into play. So if new application is up, we don't want to redeploy the HAProxy to all of our data centers. We just want to configure some map file that will be automatically downloaded, and the logic will be there.
Yeah, so in the end, we ended up with 3 different WAF instances. So the first one is API block list. So all traffic will hit that instance. And here we can apply hot patching. So we also have ability to bypass WAF. So in some cases, for example, when we are conducting some pen test or I don't know, so traffic that is not blocked on API block list will go down further, and it will end up on intelligent WAF. Yeah. So on intelligent WAF, we actually write our whitelist, and it's the end. Yeah. So.
Yeah, basically we created a traffic flow for every case that you want to have. If you have pen tester, bypass the WAF, because if they require, if we have new application, put it in learning mode. If the application is old and everything is already set up, put it in blocking mode. And we want to do the same thing basically for the new rule set. So if there is a new signature, every new signature is potentially dangerous. Why? Because it can break things. It can be a false positive. So what we want to do, we want to basically create a new signature. New signature will go into, again, monitoring mode. And when we are satisfied with the results that there is no false positive, then we will put it into the protection mode. If we are not satisfied with the result, it's going back to the fine-tuning. Again, fine-tuning, monitor it for a few days. If everything okay, put it into protection mode until we are satisfied with the result. The good thing, again, with HAProxy is that you can create multiple web application firewall filters, so you can create basically a logic for a scenario like that.
So here is how this looks like in the code. So we first defined that circuit breaker, and we put that limit, and the action is to pass through. We load our block rules, and we extended some log format with new WAF variables. In the next slide, so here you can see definition of those 3 WAF instances. So API block list and learning, those are advanced WAF instances. So here you can see that ACL IPv4 allowed clients, and in the end we have definition for our intelligent WAF. So this is advanced WAF with ModSec.
Okay, now when we, let's say, solve the challenge of classical application firewall with signature-based rule, there is always a question, can we do something more? Something more with other layers that is offered by HAProxy. And then we saw the stick tables. Basically, what's a stick table? Stick table is basically a feature is just in-memory buffer that stores some data. And this buffer called stick tables can be in the form of counters. I call it count it, depends on the condition. And now when you implement the application firewall, you basically know your application. Now you know how your application works. Why? Because you created, you fine-tune it. You know where is the login page, you know where is the unsubscribe page, or whatever you have, logout, etc. And then let's check how you can utilize these sticky tables for different type of attacks. Let's say account brute forcing is one of the common ones. Basically, in our portal, when you go to a login page and you write wrong password, you will get error code, HTTP error code. So what can you do? You can watch in time, for example, 1 minute, 5 minutes, 10 minutes. I mean, you define the threshold. You define 1 minute, and inside that 1 minute, watch the condition. The condition is if the path is login and you receive the error code, that means that is wrong password. And then count the number in the defined time, in the sliding window, for example, 1 minute. So if I see in 1 minute more than 10 times that one unique source IP had the wrong password, or basically received the error code, that is something suspicious, and for the next 5 minutes, block access for that IP. And that's basically the whole logic behind the sticky tables. And it's not that hard to configure.
Yeah, so here it's how it looks like in the code. Well, first you define that limit, then you define ACL. So here we are just looking at the paths that begin with login or sign up. Then we define ACL that will set to true. If that limit is exceeded, then we define a stick table where to store all that, and in the end is action. So it's deny. Yeah.
So the same code can be used on different type, let's say for the detection of different types of common attacks. For example, what will vulnerability scanner do on your application? On our application, it will do the redirects. Why? Because if you are not authenticated, every request will be redirected to a login page. So if I see 50 redirects from unique source IP, that is not usual for my application. So something is unusual. Why should I handle that traffic? Remove it. So block this IP. So then same with the error code. Why? And there are some specific, let's say, paths like login, logout, unsubscribe, one-time URLs, activation leaks, etc. So let's take a look at the unsubscribe. That's usually, some URL with some hashed link or something like that is unique for your email address. When you clicked, you are unsubscribed for, let's say, take for the example, some mailing lists. So that URL is unique for me. Why should some source IP, one unique source IP, why should go to the 50 different unique URLs? That's also unusual, so you can also block that traffic and deny that IP because it's not normal. But what is good is at HAProxy that you can use multiple layers like web application firewall also, and you can also put it in sticky tables, so you can define your logic. So where you can say, if the user is not authenticated, block. When you see web application firewall alert, block. But if you are authenticated, maybe I will allow 5 web application firewall violations, just to be sure if there is some kind of false positive, okay, everything will continue to work. And it's all the question, can you do something more? Why? Because for the sticky tables, for the web application firewalls, you are utilizing some kind of processing power. Basically, if you have tools like Grafana or logging tools, basically extract that information because it's malicious. If nobody create a ticket that they cannot access your application, basically put all that information into a map file, create your own threat intelligence, and block it down the way. And Boris, what was your conclusion when you were playing with HAProxy configuration?
Yeah, so with everything new, starting can be hard. So there is a steep learning curve here. So you must learn that config language. We didn't have UI, so this is now fixed in HAProxy Fusion. But yeah, engine is powerful and fast. Everything is working stable. So yeah, if you want to add something.
Yeah, basically everything that we imagine with that configuration files we can do. So we could say that at InfoBip, this multi-layered approach from HAProxy basically was a success for our implementation. Why? Because we don't have any latency issues anymore. We don't have any false positives. We don't have compliance from our customers. That is most important thing. And for the future plans, we will definitely start with the bot management module, and we will also check the HAProxy Fusion. And thank you, and that's all for now.
Amazing, gentlemen. Thank you. Thank you. So we have time for a few questions. Again, if you're in the audience, just raise your hand up nice and high so that one of the microphone runners can come find you. I think we do have one. I'll ask one that came in the chat. After setting up an app, do you still need much fine-tuning of WAF rules?
No, not anymore.
That was a quick one.
Okay, regarding the denying things that you are doing with the thresholds and so on, once the user is, or the attacker reach the threshold, you deny the request. And we all know that when you deny something, this is an information that you give to the attacker. And sometimes they try to fly under the radar and to change their behavior. Did you ever consider to use some kind of honeypots or some other tools like that to prevent from giving the attacker some valuable information?
Yes, we did. We have basically multiple thresholds, so yeah, we have this thing where we redirect them to a, let's say, false portal.
Another one in the stream. Who manages what is normal for each application? Is it the app developers?
Combination. What we are doing first, we review the logs. We take the example, for example, we took 1 month, then we create some searches in our log management solution to create some kind of statistics. And then in combination with the developer, let's say we ask him, look, by our analysis in the last month, this was like an average count of the hits. Is it okay with you that we put it, for example, 350 or 30? And if he says okay, then we go into that direction, and then we review it 1 or 2 months later again after. Why? Just to check if we can lower also from our initial search, because our initial search and our initial value is always a little bit above the threshold that we want, just to be on the safe side, and then re-evaluate after 2 months again.
Sometimes when you're conducting an investigation into a web application attack, with mod security, you have to enable additional logging so you can review the post body data. Can you do that with HAProxy's web application firewall? And if so, have you done that before?
Yes. Yeah. Yes, the answer is yes. The only thing that you should take into consider that don't enable extensive mode for some URLs that are tricky, like username and password, because you don't want to see the password of the user logged in your logging solution. So that was the only trick for us. Yeah, we are using extensive logging, but we know where are the paths, specifically on the API, where you have different ways how you can authenticate. We don't log those parameters. Yeah, we created basically also the exceptions in the log, like in the filter, don't log that, because we really don't want to have any password in our logging solution.
Have you had any issues with false positives from situations where multiple clients are behind the same IP address, like behind a NAT or something?
At the beginning, we have a huge amount of false positives. I mean, when we started, let's say like this, in the beginning, when we tried advanced WAF and mod security on its own, then we have huge amount of false positive. But when we switched to the intelligent WAF, then it was a little amount of the false positives. And I mean, after we investigate, after we fine-tune it by our needs, after that, how many? I think 1 or 2 clients only.
Yeah.
Yeah, really little.
Not much.
So when you roll out a new application, how do you determine the baseline with usage? Like, is there I guess, a process that you use to determine what's normal and what's not, besides just viewing the traffic, like from a security standpoint?
We contact our product development, basically our developers, to provide us with the documentation of the application. Yeah, to be honest, it's much harder with a web application than the API because API is always well documented. But yeah, with that application, it is a little bit trickier. But what we usually do, again, we extract the information, we contact the development team.
Excellent. Well, Jiraj, Boris, thank you so much. Appreciate it.
Thank you.
Thank you.
Thank you.